In this video, we will do exercise 11.4 of chapter Mensuration, standard 8. Before starting exercise 11.4, let us understand what is volume. Now, volume means the measure of space occupied by the three-dimension object is called volume. Means whatever the space occupied by the three-dimensional object means take for example, if any object is filled with any liquid or any solid things, so it is known as volume of that object. Now see here, cylindrical tank. Take for example any cylindrical water tank, or if we take example of a brick as such. Now we have to understand the formula for the volume of such, that is volume of cuboid. You just need to multiply all the three dimensions, that is L into B into H. Volume of a cube is all its dimensions are equal, that is length into length into length. L into L into L, that is L cube. Now volume of the cylindrical, see if we take area of one circle, and if we keep number of such circle above one another, it form one height. So area of one circle is pi r square into h becomes pi r square h. It's very simple to memorize the formula of volume. Now you have to remember this also, that is 1 meter cube equals to, see here, 10 lakh centimeter cube, that is 100 into 100 into 100. Then 1 liter equals to 1000 milliliter. In the same way 1 meter cube equals to 1000 liter also. See here, 1 meter cube equals to 1000 liter. See here, 1 liter equals to 1000 centimeter cube. 1 meter cube equals to 1000 liter. Again I have written 1 centimeter cube equals to 1 milliliter. Now let us start the exercise. Now let us see the exercise 11.4. The first question, given a cylindrical tank, in which situation will you find surface area and in which situation you will find volume? Now let us understand the question. Now we have to, according to the condition, we have to tell which situation you will find surface area and in which situation you will find volume. Now to find how much it can hold, so to find out how much it can hold, we need to find the volume of that cylindrical tank, means how much water it can hold. Number of cement bag required to plaster it. Now plastering means we need to plaster it from the outer surface. We are not filling any container, so we need to, we will have to find its surface area, not the volume. Then to find the number of smaller tank that can be filled in with water from it. Now from the huge cylindrical tank, from that we are filling the number of smaller tank. So what we will need to find? We will need to find the volume of the tank. Then only we can find how much capacity of water we can fill from it. Now let us see the next question. See here, huge question is there. The diameter of cylinder A is 7 centimeter and height is 14 centimeter. See here, diameter of cylinder A, diameter is 7 centimeter and the height is 14 centimeter. And the diameter of cylinder B is 14 centimeter and height is 7 centimeter. Now here the diameter for cylinder B, diameter is 14 centimeter and height is 7 centimeter. So they are asking that without doing any calculation, can you suggest whose volume will be greater? So if I found, just I had suggested that without doing any calculation, I say that the volume of cylindrical B will be greater as its radius is double than the cylinder. See here, the radius here, if the diameter is 14, radius will be 7. And here if the diameter is 7, radius will be 3.5. So according to that, I suggested that the volume of cylindrical tank, cylinder B, will be greater than cylinder A. Now what they are asking, verify it by finding the volume of both the cylinder. Now we will find the volume of both the cylinder. Now check whether the cylinder with a greater volume also have a greater surface area. Means after finding the volume, we need to find their area also. Now first let us find the volume of both the cylinder. First we will find the volume of cylinder A. diameter which is given 7, so radius will be 7 by 2. The formula for volume of cylinder is pi r square h. Value of pi, we have to take 22 by 7. Radius just now only we found 7 by 2. It is square, means 7 by 2 into 7 by 2, 2 times, and value of height which is given, that is 14. So write down 14 over here. After doing cancellation, we found that 539 centimeter cube. Then let us find the volume of cylinder B. Again, find here the volume of cylinder B. See, here the diameter is 14, so its radius will be 7. That is 14 divided by 2 is 7. Now the volume of the cylinder, that is pi r square h. Value of pi is 22 by 7. Radius is 7. See here the radius is 7. Just now only we found radius is 7. So 7 into 7, and the height is 7. See here the height is 7. So 7 will get cancelled. After multiplication we will get 1078 centimeter cube. The volume should always be in cube unit. Now from this we found that see here the volume of A is 539 and volume of B is 1078. So we can say that the volume of cylinder B is more than volume of cylinder A. Now as they had asked, see here, check whether the cylinder with a greater volume also have a greater surface area. That means we have to find the surface area of both the cylinder. So first we will find, that is total surface area of cylinder A. The formula is 2 pi r plus h. In our previous exercise we did such formula. Now put the formula, put the value 2, value of pi is 22 by 7. Radius of cylinder A is 7 by 2. Value of radius is 7 by 2 and height is 14. So 2 and 2 will get cancelled, 7 and 7 will get cancelled, 22 left. Now the LCM, here if you will consider the cross multiply 28 by 2, that is in this way you have to find. So equalizing the denominator, as you all know how to do, simply you have to do cross multiplication. Then 7 plus 28 is 35 and 2 common. When you will do cancel, so 2 11s and 11 35 is 385. This is the area of cylinder A. Now find out the total surface area of a cylinder B. 2 pi r in bracket r plus h. That is 2 into 22 by 7 into 7 is the radius of a second cylinder. Then the 7 is the radius and height also 7. So 7 plus 7 14. 7 7 cancel. 220 is the 44. 44 40 is the 616 centimeter square. Now hence surface area of a cylinder B is greater. See here. As the volume is also greater and the surface area, see here the surface area of cylinder A is 385 and surface area of cylinder B is 616. So we can say that surface area of a cylinder B is greater than surface area of cylinder A. We can say that hence the cylinder with a greater volume also have a greater surface area. Now let us see the next one. Find the height of a cuboid whose base area is 180 centimeter and volume is 900 centimeter. Now dear student, here we need to find the height of cuboid whose base area is 180 and the volume is also given. So let us apply the formula of volume of cuboid. So volume of a cuboid is L into B into H. So L into B is area of base. So its value is given 180 centimeter. See 180 centimeter and height we need to find, and the volume value is also given 900 centimeter cube. So see, it's very simple. L into B means area of base only. So here they had given the area of a base. If we see the figure, see L into B, this is the area of base. See, if we see the figure, L into B, this is the base part, into whatever the height created. From that we used to get the volume of cuboid. Now after doing such, and the value of H will be 900 divided by 180. So when you will get 5 centimeter. That means the height of the cuboid is 5 centimeter. After that, now let us see question number 4. A cuboid is of dimensions 60 centimeter, 54 centimeter and 30 centimeter. There is length, breadth and height is given 60 centimeter, 54 centimeter and the height is 30 centimeter. Now how many small cube with the side 6 centimeter can be placed in the given cuboid? Now dear sir, in the given cuboid, how many number of a cube with side 6 centimeter can be placed? So we need to find the volume of both the surfaces. Now see, both the object means the dimension of cuboid Dimension of cuboid is 60 centimeter into 54 centimeter into 30 centimeter, that is length, breadth, height. And dimension of a cube, that is cube means square object, that is its dimension will be same from all its sides, edges are the same, that is 6 centimeter, that is length, breadth, height, all are same, 6 into 6 into 6. So what we will do, we will divide the dimension of cuboid by the dimension of cube, so that we can easily find how many number of cube can be placed in the given cuboid. What we will do, see, number of small cube. How many number of small cube will come? The volume of cuboid divided by the volume of cube. So L into B into H divided by L into L into H. When we do cancellation, so you will get 450. That means we can say that 450 such cube can be placed in the given cuboid. So small 450 cubes can be placed in the given cuboid. Now, fifth one, find the height of the cylinder whose volume is 1.54 meter cube and the diameter of the base is 140. See, dear student, here again the volume is given and the diameter of the base, that is 140, that means the radius will be 70. So we need to find the height. So again what we'll do, again we will apply the volume of cylinder. The formula is pi r square h, and the volume is given, the value of volume is given 1.54 meter cube. So dear student, here the volume is given in meter cube, but the diameter, that the radius, is given in centimeter. So we will convert this. Now see here, the volume of cylinder pi r square h, the value of volume of cylinder is given, that is 1.54 meter cube. So convert that the decimal into fraction, 154 upon 100 into pi value 22 by 7. Radius is, see dear student, the value here, the value of radius is in centimeter. I had converted into meter, that is 1 centimeter equals to 1 by 100 meter. So when you will divide 70 by 100, you will get 0.7. Now that means the value of radius will be 0.7 means 7 by 10. The value of radius will be 7 by 10 into 7 by 10 into h. The value of h we are finding. Now do cross multiplication, 10 and 10 will come over here. See, 150 into 10 into 10, and 100 will, see, 22 into 7 into 7 will come down. 22 into, here 1, 7 and 7 will get cancelled. So 22 and 7 is left. Now when you will do cancellation, you will get how much? 1 meter. Only 1 left. So hence the height of the cylinder is 1 meter. Now let us see question number 6. A milk tank in the form of cylinder whose radius is 1.5 meter and the length is 7 meter. Find the quantity of milk in liter that can be stored in the tank. So for this we need to find the volume of cylindrical tank. See, this kind of a cylindrical tank is there, in which whose radius is 1.5 meter and the height is 7 meter. So radius 1.5 I had converted into fraction, that is 15 by 10, and the height is 7 meter. Now the volume of cylinder is pi r square h, value of pi is 22 by 7, radius, that is 15 by 10 into 15 by 10, and the height is 7 meter. When you will do cancellation, you will get 49.5 meter square. As you all know, 1 meter square equals to 1000 liter, so multiply 49.5 by 1000. So when you will multiply, you will get 49,500 liters. So hence 49,500 liters of milk can be stored in the tank. Now let us see question sum number 7. If each edge of cube is double, means suppose if take for example one cube is there, if each edge is double, see here, so how many times will its surface area increase? Means if the edges of the cube, here no, the length of dimension of the cube is not given. I had supposed it as an x. Now if such value is double, so how many times its surface area will be increased? So that only we have to find. The first we will do, what we will do, let the edge of the original cube be x. I had supposed it as x, that is length into length into length is x. So let us find the original surface area, that means 6 side square, that is 6 side is x, so x square is 6x square. Now the new surface area whose dimension, that is here it is given. See, the edges of the cube is double. Now here the edges, if the edges is x, so here it will become 2x. Now if we find a new surface area, see, new surface area we have to find over here, that is 6 side square. 6 side square means 6. Now the edges, now the length of the edges are 2x. So 2x square, so it will become 4x square. So 4 6 are 24x square. Now the original surface area is 6x square and the new surface area is 24x square. Now to find the how many time will its surface area increase, so what we'll do, so we'll divide the new surface area by the original surface area, that is 24x square divided by 6x square. X square will get cancelled. 6 4s are 24, so 4 times, so we can say that hence the surface area of cube will be increased by 4 times. In that only one more question is there. So how many times will its volume increase? Now if the original edges is x, so original volume will be side cube. Volume of cube is side cube. So cube of x will be x cube. Now the new volume, if the edges increase by double, if x is there original, so it increase by double, so become 2x. The volume of the new cube will be side cube, that is x cube. 2x cube gives 8x cube. So now to find out how many times the volume increase, the new volume of the cube should be divided by the original volume of the cube. So 8x cube divided by x cube gives 8. So we can say that the volume of the cube will increase by 8 times. Now let us see sum number 8. Water is pouring into a cuboidal reservoir at the rate of 60 liter per minute. Now here one cuboidal reservoir is there. See this kind of a reservoir, water tank. In that the water is poured at the rate of 60 liter per minute. Now if the volume of the reservoir is 108 meter cube, find the number of hours will it take to fill the reservoir. Now its volume is 108 meter cube. So when you will convert it into liter, so means 1 meter cube equals to 1000 liter. When you will multiply 108 into 1000, so we will get that means the capacity of the water tank is 1,08,000 liter. This is the volume we have. Now what we'll do, how much time it take? Now if we see, it take per minute it fill 60 liter. So in 1 hour there are 60 minutes. So what we will do is we will multiply this 60 by 60. So we will get, so in 1 hour it fill 3600 of liter, means water pour in a minute is 60 liter, and in 1 hour there is 60 minutes. So this 60 liters should be multiplied by 60 minutes. So we will get in 1 hour, that is in 1 hour it fill 3600 of liter. Now how much time it take to fill the whole tank? The volume of whole tank is 1,08,000 liter. So this 1,08,000 should be divided by number of water filled in 1 hour. So 3600 liter fill in 1 hour. So time taken to fill the reservoir, that is volume of the reservoir, that is 1,08,000 should be divided by water pour in 1 hour, in an hour, that is 3600. When we will divide and cancellation, we will get 30 hours. So we can say that hence 30 hours it will take to fill the reservoir.